Recently, I made a video on stop entrance pupil and exit pupil of a optical system, and Maxwell Quada Busa asked a very good question. So I decided to answer his question, make a video with more details on the stop of optical system and entrance pupil and exit pupil, and answer to this question that how we can find the actual stop of a optical system. So the stop of our optical system is the aperture stop. We have two concepts. One is the stop of our optical system, that it is a limitation of the bundle of the light that can propagate through our optical system. So in Zmax, you always need to make sure that you set your stop. And usually we use aperture stop for different apertures and select which, or actually find which one is the real stop of our optical system. Or we can just call it aperture. So as I mentioned before, the stop of the optical system can be a diaphragm, metallic pinhole, or any circular object, or it can be the edge of the lens. Because when you look at the edge of the lens, we have clear aperture, and from that edge to the outside environment, we have some kind of separation, and or we can have a retaining ring or anything. So it can be a retainer ring, any mechanical surface can be our stop of our optical system. But now the question is that how we can find that stop, because the stop is a very important optical uh, feature for our optical system. When you find the real stop of your optical system, then the image of a stop into object space is your entrance pupil, that we call it EP. That's very important. And then the image of a stop through image space, that your CCD side, is exit pupil, that we use XP for that. So when you find all these three parameters, your optical system is very well known. So right now the question is, it's not very obvious to find the stop, the limiting aperture of our optical system. It can be anything, it can be anywhere, it can be in image space, it can be in object space. Now in this video, we want to answer to this important question: how we can find the stop of our optical system. And when we find the stop, the rest is easy. We can find the entrance pupil, exit pupil of our optical system. So let's take a look at a simple optical system. We have a three lens system, hook triplet. We have lens 1, lens 2. This is positive, this is negative, and this one is positive. And we have a aperture here. So let's say it's a mechanical aperture with constant diameter. So for this aperture, we call it A3. But we have another apertures also. From here to here, we have a uh, clear aperture of the lens that is, as I said, it can be mechanical edge of the lens, anything. So we have three other apertures: aperture 1, aperture 2, and aperture 3. As I mentioned, it's a mechanical aperture, and aperture 4. Now it's very obvious that aperture 3 is the limitation of our optical system, and that's the real stop of our optical system. But we need to figure it out. We need to see that is it a true statement or not. From the first perspective, yeah, that one is the smallest one, so that should be the stop of our optical system, because the rest of the system we have bigger apertures. So the minimum aperture is A3. But now let's see, is it a correct guess or not? So in order to find the real stop, we should use this methodology. That's one of the methodologies that we can use for finding the stop. So we image all the apertures in our system, like aperture 1, aperture 2, aperture 3, and aperture 4, into object space. Here, this is the object space. Here, we have image space. So if we image each element into this space, which means that, for example, for aperture 3, on the left-hand side, we have two lenses. We should image it through these two lenses. For aperture 4, we have two lenses. We need to image it. For aperture 1, there is no lens after aperture 1. So aperture 1, entrance pupil 1 is the same. Now we want to answer this question: which one is the main stop of our optical system? So aperture 1 is pretty simple. There is no lens after aperture 1, and that one we call it entrance pupil, EP1. Let's say this is EP1, the same size, the same location. Now, as I said, for aperture 2, we need to image it through this lens. It looks like it's pretty close, so the image, entrance pupil 2, which is the image of this aperture, it can be somewhere, it can be anywhere, it can be into object space, image space. We just image it. As you can see, this is a virtual image. So EP2 is the image of aperture 2. And as you can see, the height is a little bit higher. So aperture 3, which is a physical aperture, now we need to image it through these two lenses. So we image it. The image is somewhere, is in object space. So that's EP3, the image of aperture 3. That's the EP3. Now aperture 4, which is the last lens, we need to image it through the whole system. And it goes somewhere in the middle. So that's EP3. Now we have all EPs or entrance pupils. Now we want to see which one is the main one. So from a point in object space, we call it O, we connect lines from that center to the edge of apertures. So we connect one line to EP3, EP1, EP4, and EP2. Now we have, for each of them, we have a angle that is associated, for example, with EP2. We have another angle associated with EP4, another angle associated with EP1 and EP3. The smallest one is the limiting aperture of the system. Now it is obvious that EP2 is the smallest one. So EP2 is the entrance pupil of the system, which is related to aperture 2. So right now, my first guess that was A3 is wrong. So A2 is the aperture stop of the system. But visually, it looks like it's bigger than this one. But because of this is the imaging system, the main stop of our optical system in this case is A2, because the entrance pupil of E2 is the smallest angle. So now the rest is easy. Now you find your main stop, you image it through into object space, you find an entrance pupil. You know, entrance pupil can be anywhere. And then again, you image it through image space, and you find your exit pupil that can be anywhere. Again, it can be on the right hand side, it can be on the left hand side, it can be anywhere. So this is a method that we use for finding aperture stop. Now let's take a look at a real example, how we can find it in reality. Let's say we have this optical system, we have two lenses, and we have a mechanical stop in between. First lens, F is equal to 20, the diameter is 15, and 5 millimeter after the first lens, we have the stop, the diameter is 12, and 8 millimeter after that stop, we have another negative lens, F is negative 12, and the diameter is 5 millimeter. Now, we should guess which one is the stop of our optical system. My guess is that this is a mechanical stop, so that's the main stop of my optical system. But now let's see which one is the main one. So as I mentioned before, we have EP1, entrance pupil 1 for the first lens, and because there is no lens on the left hand side, it's just entrance pupil 1 is the image of this lens to the object space. The location, let's put our coordinate system at the center of the lens, and all is paraxial approximation. So don't worry about putting using paraxial approximation, because that's just a test to see which one is the main one. So the location is 0, the size is 15. Size is 15, the diameter of the lens. So entrance pupil 1 is easy. Now let's see what about entrance pupil 2. So we have a aperture here, which is 12, 5 millimeter distance from this lens. We need to image it. So paraxial approximation 1 over I plus 1 over O image object is equal to 1 over F. So 1 over I is equal to 1 over 20, which is the focal length of this lens, minus 1 over 5, which is the distance from here. And then after solving this equation, you find that I is negative 6.66 millimeter. So it should be on this side. And then that's the first parameter, the position of the image. Now we need to find the height, 12, which is this diameter, divided by distance, which is 5, equal to the height divided by distance. Distance is 6.66, and the height is 19. So we know that this is a negative number, so aperture internal pupil should be somewhere here. So if we just put it somewhere here, that we know the location is negative 6.6, the size is 19.98. Now let's look at internal pupil 3, which is the same. If we image this lens through this optical system to the left hand side, the distance is 5 prime 8, 5 plus 8, which is 13, and the focal length of distance is 20, so 1 over 20 minus 1 over 13 is negative 3.714. So that's the image is very far in this direction, negative, and the height is 5 over 13 equal to height over 37.14. The height is 14.28, so it's close to 15. So that's the interance pupil 3, is somewhere there. So we have interance pupil 1, interance pupil 2, interance pupil 3. Now let's look at all of them together. So interance pupil 1, location 0, height 15. Now 6.6 millimeter after that, we have interance pupil 2. The height is a little bit bigger than 15, so it's a little bit wider. And then 37.14 from the first lens, very far from that, we have another aperture, which is EP3, and the height is 14.28. This is the height. So you can see this one is roughly close to this, 15, 14.28, but it's very far. So even visually, you can see that this angle is smaller than these two. So the minimum angle or the limit on our optical system is interance pupil 3. So it's right now it's very obvious that this is not the main stop. The main stop is this lens. So that's the aperture stop of our optical system. And in order to find the interance pupil, the rest is easy. You image the stop into image plane that we did before. That's your interance pupil, and you image your stop through the image space to find your exit pupil. So you can see it's very obvious. There is no lens after this this last lens. So the exit pupil is exactly the same as the stop of our optical system. So that's the method that we use for finding the stop. First, we should find the stop, theoretically find it, and then even we can use Zmax for doing ray tracing. After we find the stop, then we image it left hand side and right hand side to find interance pupil and exit pupil of our optical system. Here are some references that I use for this video. Thank you very much.